I'd like to talk about the new Renesas RZ G3E. It's a MPU with 4 cores, very high clock rate, Cortex A55, quite a lot of RAM. It has a GPU. We've just certified it, and we're excited to be using the OpenGL driver with it. It gets fantastic performance with very short render and flush time. These benchmark results are actually superseded by some tweaks that we were able to make in the driver since then, and it can achieve even 3 millisecond flush time compared to the constant 7 here. That driver has been under a lot of development, and it's improved and become this fantastic driver, and it's only going to get better from here. You will need a special kind of USB-C power adapter that's capable of 65 watts. The type is specified quite well in the getting started instructions. You will need to make these connections, connect a USB port to your computer, USB cable to your computer to access the serial terminal, connect HDMI to a monitor, connect Ethernet to transfer files more easily. Here's the store page, and this is the getting started guide. It's necessary to flash the bootloader by following this guide. It is a pretty involved process, so make sure you follow all the steps very carefully. It involves using terminal software called Teraterm for uploading files over serial. There's a trick that you can do if you're not using Teraterm. If you're on Linux, you can once the serial terminal has been created, it's already configured the serial ports to the correct settings, and you can actually cat a file to it like this. And then if you run that, it will send the file at the right time. And then when you're finished, you can go back to the terminal. I'll turn it on now. So I've just pressed the red button for 2 seconds, and it's booting up. This has already had the SD card flashed. I explained this trick here for catting the file to it. There are a lot of artifacts or large files that you need to have ready to go in order to use this board, including the SD card image and this SDK, which is the cross compiler toolchain for building software for the board. This is a Yocto project, and the recommended way to customize, well, the only way to customize the image is to use Yocto. Allows you to basically configure a Linux image any way that you desire. The basic one is available here, and you can use that one directly. Once you've done that, you can clone this repo that we have. It's an LV port Linux repo, and we maintain it very well. After you've cloned it, you can open the project. I'm going to use VS Code, but you don't have to. To activate the toolchain, make sure you run this script, which enables the environment variables. You can see that now the compiler environment variable is set to this. I've chosen to use the benchmark demo, and then you can run the build commands to compile it. And that will create a binary in the build directory here. And you can upload that to the board any way you like, but I find a nice, easy way is to use Ethernet. So I can get the IP address of the board, and you can use SCP to send the file to it. There's already a file here. I'll remove it. And then I can do SCP root at IP address :/root. I think it's root. Yeah, root slash. That's the destination. The source will be build/bin/LVGL sim. It's uploaded, and there it is. So this is an EGL driver-based project. So you need to stop the Wayland desktop in order to use EGL, because it uses the DRM directly. Oops, not here. And now you can run program, and now you can see on my face the reflection of the screen as it flashes all the colorful rectangles. You can control the width and height of the screen if you're using Wayland. So you can use OpenGL, you can use DRM, you can use Wayland. It's pretty easy to change them. If you're using Wayland, you can specify the width and height by invoking the LVGL sim command with these flags. I'll show how easy it is to change those configs really quick. So here are the configs that override the defaults. In order to use Wayland, you can simply enable it, and I'll disable OpenGL. You don't need DRM for this. Yep, save that, and then you can do LV port Linux, LVGL scripts, generate LV code, and now you can recompile. The benchmark is finished. It prints the results. I just wanted to close out by saying that you do not need to RM the file every time you SCP a new one. Just make sure it isn't running, because it will deny the upload. And then the other thing was, in order to do a graceful shutdown so that you don't corrupt the SD card, make sure to run power off and wait till all the output stops, and you can press the red button for 2 seconds until the lights change, and then you can unplug it safely. By the way, the PDF that has the quick start guide is also available in the repo.